Hello learner, welcome to Manifestant e-learning platform. My name is Purity Anzelimo, and our subject today, what I'll be taking us through is physics. Yes, and during our lesson today, we are going to look at electromagnetic spectrum. Electromagnetic spectrum is a topic in book 4. That is what we are going to look at during our lesson. So we have the electromagnetic spectrum. And as I've said, is one of the topics in book 4. And this we are going to relate a lot with what we covered in book 2 under the topic waves. So we are going to borrow a lot from the topic waves in book 2 and also in book 3. Yeah, because as you can see, we have the electromagnetic spectrum, and in book 2 we learned about the electromagnetic waves. So by the end of this lesson, you should be in a position 2. So we have the objectives for this lesson. You should be in a position 1 to describe fully a complete spectrum. That is a complete electromagnetic spectrum. You should be in a position to explain what an electromagnetic spectrum is. So by the end of the lesson, you should be in a position to explain the electromagnetic spectrum. Electromagnetic spectrum. That's 1. And number 2, by the end of this lesson, you should be in a position to state the properties of electromagnetic waves. State the properties of the electromagnetic waves. State the properties of the electromagnetic. We abbreviate it as EM, electromagnetic waves. So that is what you should be in a position to, by the end of the lesson, explain the electromagnetic spectrum. What is an electromagnetic spectrum, as we have our topic, and what are the properties of the electromagnetic waves. So to begin with, we are going to deal with, or we are going to define what we are calling the electromagnetic waves, so that we can be able now to define what an electromagnetic spectrum is all about. So we are going to start with electromagnetic waves. Electromagnetic waves. So from Waves Book 2, what are electromagnetic waves? When we talk of electromagnetic waves, we say that these are waves that do not require a material medium for their transmission. They are waves that do not require a material medium for their transmission. That is simply what we refer to as the electromagnetic waves, or what we call the EM waves. They are waves that do not require a material medium for their transmission. Remember, we gave 2 categories of waves in Form 2, whereby we looked at the electromagnetic waves and the mechanical waves. And one of the major differences between the electromagnetic waves and the mechanical waves is that for the electromagnetic waves, they do not require a material medium for their transmission, whereas for the mechanical waves, they require a medium for their transmission. And these electromagnetic waves, again, we can define it as, because we say that all electromagnetic waves are transverse in nature. Remember that all the electromagnetic waves are transverse. They are transverse in nature, meaning that the vibration of their particles is at right angle to the direction of wave travel. And therefore, we can also say that electromagnetic waves, we can say that they are produced by the oscillating electric and magnetic fields at right angle to each other. So we can say that they are produced or they are formed by the oscillating, they are formed by the oscillation or the oscillating magnetic and the electric fields at right angle with each other. So those are the EM waves. We have seen that they can be transmitted through a vacuum because they do not require a material medium for them to be transmitted. Then we are also saying that all the electromagnetic waves are transverse in nature. And we are saying, therefore, it means that the vibration of their particles is at right angle to the direction of the wave travel. And that's why we are saying that they are produced by the oscillating magnetic and electric fields at right angle with each other. So these are the electromagnetic waves or the EM waves. Now we need to list down those electromagnetic waves that we are talking about. So we list down, they include the electromagnetic waves or the EM waves include. So we have various, or we have electromagnetic waves, examples of electromagnetic waves. We can list them down in any order. We have what we call the gamma rays. Gamma rays is an example of an electromagnetic wave. We also have what we call the microwaves. The microwaves. We also have the visible light. The visible light. We also have the infrared radiation. The infrared radiation. We also have the ultraviolet radiation, or what we call the UV radiation. The ultraviolet radiation. We also have what we refer to as the X-rays. We have the X-rays as an example of the electromagnetic waves. We have the X-rays. So we have the gamma rays, we have the microwaves, we have the visible light, we have the infrared radiation, we have the ultraviolet radiation, and we also have the radio waves. Radio waves. So these are our electromagnetic waves. Remember where we have come from? We want to define an electromagnetic spectrum. And we have started by asking ourselves, what are these electromagnetic waves? And we are saying these are waves that are produced by oscillating magnetic and electric fields at right angle with each other. And we have the list of the electromagnetic waves. We have the gamma rays. We have the microwaves, we have the visible light, we have the infrared radiation, ultraviolet radiation, we also have the X-rays, and we also have the radio waves. Now all these waves that we have listed down are what we are calling the EM waves. And these waves, as we have seen, they are transverse in nature, meaning that also they have sections of crests alternating with troughs. That is what we said in book 2 on waves, that when we talk of a transverse wave, it has sections of crests alternating with troughs. And note that all these electromagnetic waves, we are saying that they are waves in nature. And therefore, when it comes to the properties of the electromagnetic waves, we'll also be looking at some of the properties of waves as learned in book 3 under waves 2. So we have these electromagnetic waves. Now the way they have been arranged, they have been mixed up. There is no formula that I've used to arrange these electromagnetic waves. But now we can arrange these waves in order of their wavelengths or their frequencies. If we arrange these electromagnetic waves in order of their frequencies or in order of their wavelengths, then we are going to form what we call an electromagnetic spectrum. And that's what I want us to do. So we want to arrange these electromagnetic waves, the waves that we have listed down, we arrange them in order of their frequencies or in order of their wavelengths. Remember those two terms, wavelength and frequency. Wavelength, always represented by a Greek letter lambda, and then we have the frequency. Frequency represented by a small letter f. So we have wavelength, and we say that wavelength simply refers to the distance covered in one complete oscillation. So remember that distance covered in one complete oscillation is what we are calling the wavelength. And we say that the SI unit for wavelength is meters. That is the SI unit because it is distance, and distance is length, and the SI unit of length is meter. Then we have frequency, and when we talk of frequency, it simply refers to the number of complete oscillations in 1 second. Number of complete oscillations in 1 second. And we say that the SI unit of frequency is hertz. So that's what we have. Now we want to arrange these electromagnetic waves in order of their wavelength and in order of their frequency. So we start with the one that has the smallest frequency, and we have what we refer to as the radio waves. It has the lowest frequency or the smallest frequency, followed by the microwaves. We have the microwaves, followed by the infrared radiation. We also have now the visible light. Visible light. Then we have the ultraviolet radiation. Then we have the X-rays. And finally, we have gamma rays, which have the highest frequency. We have the gamma rays. So if I were to draw an arrow to indicate the increasing frequency, so this is increasing frequency. So we have radio waves. They have the lowest frequency all the way to gamma rays. So gamma rays have the highest frequency. But now when it comes to wavelength, these two are inversely proportional. When it comes to the wavelength, if we have this as the increasing wavelength, then it means that when we'll have it this way now for the wavelength. For the wavelength, we have gamma rays, which have the lowest wavelength. So we have increasing. So we have the increasing wavelength. So you should be keen. We have gamma rays. Gamma rays have the highest frequency, but have the lowest wavelength. They have the highest frequency, but have the lowest wavelength. Then the radio waves have the highest wavelength. The radio waves have the highest or the largest wavelength, but they have the lowest or the smallest frequency. So that is it. So when these electromagnetic waves have been arranged in order of their frequency or in order of their wavelengths, then what they form is what we refer to as an electromagnetic spectrum. So this that we have here, the radio waves, the microwaves, the infrared, the visible light, the ultraviolet radiation, the X-rays, the gamma rays, the way they have been arranged is what we refer to as an electromagnetic spectrum. So for an electromagnetic spectrum, so for the electromagnetic spectrum, we have the following electromagnetic waves. We have seen that when the electromagnetic waves have been arranged in order of their frequency or in order of their wavelength, they form an EM spectrum. So they can be either maybe the increasing frequency or the decreasing frequency, or the increasing wavelength or the decreasing wavelength. So provided they have been arranged in a certain order of their frequencies or their wavelengths, then we'll say that they form an electromagnetic spectrum. So our electromagnetic spectrum, we are going to have, therefore, if we start with the one that has the lowest frequency, that is the radio wave. So we are going to have radio waves. We have the microwaves. We have the infrared radiation or the infrared. We have the visible light. The visible light. We also have the ultraviolet radiation. We also have the X-rays. And finally, we have the gamma rays. So all these arranged in this order, they form an electromagnetic spectrum. And therefore, we can be able to define what an electromagnetic spectrum is. So an electromagnetic spectrum is simply electromagnetic waves arranged in order of their frequencies or wavelengths. So these are electromagnetic waves. They refers to the electromagnetic waves arranged in order of their frequencies or wavelengths. Electromagnetic spectrum refers to electromagnetic waves arranged in order of their frequencies or wavelengths. And as we continue, we'll be able to see, now that we are seeing that radio waves have the lowest frequency, gamma rays have the highest frequency. Therefore, we'll be able to see that therefore the 2 or the 7 electromagnetic waves have different energies, or they possess different amounts of energy, because energy depends with the frequency and also the wavelength. So that is the electromagnetic spectrum. So if you are told to define what an electromagnetic spectrum is, then it simply refers to the electromagnetic waves arranged in order of their frequencies or wavelengths. And we'll continue and get now to the properties. So those are the that is the electromagnetic spectrum, and you should also be in a position to arrange all those electromagnetic waves in order of their wavelengths or in order of their frequencies. So if you know one, for example, you know that the radio waves have the smallest frequency, followed by microwaves all the way to gamma rays. So if you know one of them, the frequency, then you should know that the wavelength is the vice versa, the other way around. So if the radio waves, we are saying that they have the smallest frequency, then it means that they have the largest wavelength. Gamma rays have the highest or the largest frequency, and they have the lowest wavelength. So make note of that, because you can be given in an exam, you are given examples of some electromagnetic waves, and you are told to arrange them maybe in order of their increasing wavelength, or maybe in order of their decreasing frequency. So make note of that. Then something else I want to emphasize on before we go to the properties of the EM waves. At this point here, the visible light, when we talk of this visible light, as you learned in reflection of light, the dispersion of white light, the visible light comprises of the 7 colors of the rainbow. So here in the visible light, is where we have the colors like the red, and we have the region. So in the visible light, we have the region of yolk, gained, button, in vein. So we have the red, we have the orange here, we have the yellow, we have the green here, we have blue, we have indigo, and we have the violet color. So in case maybe you are told that blue light, for example, you are told arrange the following in order of their increasing frequencies. And you are given, for example, infrared, microwaves, X-rays, and you are given blue light. You should know that blue light is one of the visible light, or it's invisible light, because that's what we learned in refraction of light. That's the dispersion of white light, which comprises of the 7 colors of the rainbow. So that is all on the electromagnetic spectrum. You need to know how to arrange these waves in order of their frequencies and wavelengths. So I want us to move on and look at the properties of these waves. Yeah, because we are saying that they are waves in nature, they are transverse waves in nature. So we have various properties of the electromagnetic waves. So let's look at the properties of electromagnetic waves. Properties of electromagnetic waves. And one of the properties that we have just stated when I was introducing the lesson, we have seen that number 1, the electromagnetic waves are transverse in nature. They are transverse waves. So number 1 is that they are transverse in nature. They are transverse in nature. So the EM waves are transverse in nature, and we have seen that they are produced by the oscillating magnetic and electric fields at right angle with each other. So that is one of the properties. Then we have also seen that the electromagnetic waves do not require a material medium for their transmission. So that is another property, that they do not require a material medium for their transmission. And therefore they can also be able to be transmitted through vacuum or through space. So they do not require a material medium for their transmission. Something else that you need to note about the electromagnetic waves. Electromagnetic waves travel with the speed of light. They travel with the speed of light. And the speed of light, that is the speed of light is 3 times 10 power 8 meters per second. So that is another property. They travel through space with the speed of light. They travel with the speed that is 3.0 times 10 power 8 meters per second. So if you are given a question, because we'll now also get into numerical calculations, when you are told, for example, infrared radiation, and you are told maybe to calculate, for example, maybe the energy, you have not been given the speed, always know that the speed of any of the electromagnetic waves is 3.0 times 10 power 8 meters per second. That is for all those electromagnetic waves. So they travel with the speed of light, which is 3.0 times 10 power 8 meters per second. Then something else, because we are saying that these waves, we are saying that they are waves, and therefore they will undergo the following. So they undergo, since they are waves, they undergo diffraction. You talked about diffraction in waves 2. They also undergo reflection. They also undergo interference and polarization effects. All these are properties of waves. They undergo diffraction, reflection, interference, and polarization effects. And because these EM waves are also waves, they will also undergo the same. So they undergo diffraction, reflection, interference, and the polarization effects. Then we can also say another property is that they will possess energy. As I had mentioned earlier, we are saying that they have different frequencies. They have different frequencies. Gamma rays having the highest frequency and radio waves having the smallest frequency. So we can also say number 5 that they possess energy. They possess kinetic energy. We can talk of kinetic energy in different amounts depending with the, just talk of energy. They possess energy in different amounts. We are going to do the calculations. You will get the formula that we use to know which one contains higher amount of energy than the other. We'll get to that in our next lesson. So they possess energy in different amounts. And we have seen that since the gamma rays have the largest frequency, they will actually have the highest amount of energy. So just know that they possess energy in different amounts. Then finally, we can say that they carry no charge. Number 6, they carry no charge. And therefore, they are not deflected by either the magnetic or the electric fields. So they are not, we can say that they are not affected by electric and magnetic fields. They carry no charge. So they are neither positively nor negatively charged, but they carry no charge with them. And therefore they are not affected by either the electric, we can add by either, they are not affected by either the electric or the magnetic fields. And those are the properties of the EM waves. We have said that they are transverse in nature. In book 2, you learned what are transverse waves. Transverse waves are waves whose vibration of particles is at right angle to the direction of wave travel. Number 2, they do not require a material medium for their transmission. They can be transmitted through a vacuum. Number 3, they travel with the speed of light, which is 3 times 10 power 8 meters per second. Number 4, waves, they will undergo diffraction, reflection, interference, and polarization effects. And number 5, they possess energy in different amounts. And when we come to the uses of the electromagnetic waves, we'll be able to state the uses depending with also the amount of energy that the electromagnetic wave possesses. Then finally, number 6, we have seen that they carry no charge, and therefore they are not affected by either the electric or the magnetic fields. So that is on electromagnetic spectrum. I would like to do an exercise. Number 1, state 5 properties of the EM waves. State 5 properties of the electromagnetic waves. Number 2, arrange the following in order of their wavelengths. Arrange the following in order of their wavelengths. So we have the following EM waves. We have infrared, green light, ultraviolet radiation, radio waves, and X-rays. So we have the following: infrared, green light, ultraviolet radiation, radio waves, and the X-rays. Arrange them in order of their wavelengths. Then question number 3. Question number 3. Why is sound not an electromagnetic wave? Why is sound not an electromagnetic wave? We know that sound is also a wave, but we are asking, why is sound not an electromagnetic wave? Number 4. Question number 4. Name one radiation of electromagnetic spectrum. Name one radiation of electromagnetic spectrum which has a higher frequency. Name one radiation of EM spectrum which has a higher frequency than the visible light. Which has a higher frequency than the visible light. So name one of it which has a higher frequency than the visible light. And finally, number 5, give two differences. Give two differences between electromagnetic waves and mechanical waves. Give two differences between electromagnetic waves and mechanical waves. So you give two differences between the EM waves and the mechanical waves. Differences between the EM waves and the mechanical waves. So that is all on our lesson today. We have been able to achieve the two objectives that we had. One, to define an electromagnetic spectrum, which we have said an electromagnetic spectrum simply refers to the electromagnetic waves arranged in order of their wavelengths or frequencies. Then number 2, we've also been in a position to state the properties of the EM waves. And they are here. We have said they are transverse in nature. They do not require material medium for their transmission, travel at the speed of light, undergo diffraction, reflection, interference, and polarization effects. They possess energy in different amounts, carry no charge, and hence not affected by either the electric or the magnetic fields. So that is it. When you do this exercise, you'll be in a position to see whether you have captured the lesson well. And during our next lesson, we'll now be calculating this energy. Now that we are saying that they possess energy in different amounts, we'll now be able to calculate the energy that is possessed by the electromagnetic waves. Thank you for following. Till we meet next lesson.